And that takes us to the flow control of TCP. Allow me to explain. Okay, so this is again the protocol stack. This is the application layer, transport layer, and the network layer. And packet is coming in from below like this. So network layer is going to pass the segment to the TCP receiver right here. Okay. If everything is okay, TCP receiver is going to extract data and pass it further up. Okay. What's going on really in the implementation, in the operating system is this. That data does not go directly to the application layer process. There's this place here called the receiver buffer. So the packet being extracted is actually temporarily stored here, okay, waiting for the application layer process to fetch it. So the application layer process is going to remove data from the receiver buffer. Okay. Just like the TCP receiver here is going to push more data into the receiver buffer. Okay. And TCP flow control is needed when the application is drawing data slower than TCP receiver there, delivering data up. Because when that is the case, the buffer space will be what? Occupied. More and more and more and more, because outgoing slow, incoming fast. And eventually the space is going to be exhausted. The subsequent data will be dropped right there between TCP receiver and the receiver buffer. And this is super bad because TCP here is working very hard to try to get this packet in. Okay. So flow control there is this. For the receiver to tell the data sender, slow down a little bit so that you will not be overflowing the receiver buffer by transmitting too fast, too much. And the way flow control works is this. It works by tracking this variable, RWND. Okay. In the operating system, there's this receive buffer. This is well defined, and it's actually the size of the receive buffer space. Okay. Now, initially, RWND is going to equal the receiver buffer. Whenever TCP receiver sends data to the upper layer, this RWND is going to be subtracted by the amount of bytes being passed up here. Whenever the application layer process is drawing data out of the buffer, the RWND is going to be incremented by the number of bytes there. So RWND is essentially tracking this, the free buffer space. So once we manage to track the free buffer space, TCP receiver here will advertise the free buffer space by including RWND in the receive window field in the packet header, in the TCP packet header, and send it back to the sender. And that's when sender knows it needs to limit its sending window so that it's smaller than RWND. So you see here at the sender side, the sending window not only is limited by the congestion control mechanism, but also by flow control mechanisms, RWND. And that guarantees the receiver buffer not being overflowed. So receive buffer here, in most of operating systems, when you create a socket, it's set default to 4096. But most of the modern operating systems these days would actually give you different receive buffer space by default. If there's more space, then this is potentially higher. Okay. Last is the connection management of TCP. There are two parts. First is establishing connection. Second, breaking a connection. Let's talk about the process of establishing connection. It needs to be done before exchanging data, and the process is called a three-way handshake. Okay. At the end of the process of three-way handshake, we would establish a connection, or aka a socket. Okay. So once the socket is established, two ends can begin sending data to each other. So the socket establishment process is also exchanging some number of parameters. Now this is crucial because later on, when the client over here on the left is trying to send data, in the packet header there, it needs to carry a sequence number. When that packet arrives at the receiver, which is the server is going to examine the sequence number in the packet header to decide whether to extract the data out and pass it up to the application layer. And when do we extract the data? Only when the sequence number equals the expected sequence number. Okay. So there is a certain parameter at the receiving part, that needs to be initialized. And because either side can be sending data, receiving data. So server here would also need to tell the client what is the initial sequence number server will be using. Therefore, the client can set the expected seek num accordingly. And this illustrates the three-way handshake. Client, server, both initially just listening, and client at some point wanting to request some data will then initiate connection, dial into the server. So it's gonna choose an initial sequence number to tell the receiving of the request messages, and it's gonna be sending a TCP sync packet or sync message. Now, if you recall back in TCP packet format, in the header part of it, there are a number of these flags one can set. So sync packet is the packet with the sync flag being set, the S flag being set. That is also called the sync bit. So that bit is going to be turned to 1, and the initial sequence number is going to be in the packet somewhere. And that packet is going to arrive at the receiver, which is the server. So client, after sending the data, is going to be in the sync packet already sent state. Now the server will then in the sync received state. So server here will be doing two things. First, send back an ACK, to tell the sender of the sync packet that the sync packet is received. So sync ACK is such a packet. That is to ACK, receiving the sync packet. The server here will be doing yet another thing. Choosing its own initial sequence number, and let's say it's Y, and this Y will be stored somewhere in the sync ACK packet as well. So you see here, this packet goes back, and the sync ACK packet is going to have the sync bit on as well as the ACK bit on. And in sequence number, server tells the client it's going to start from Y. And this being an ACK packet is going to tell the sender of the sync packet that, hey, the next one I'm expecting is X plus 1. So next seek num is already set to X plus 1. And lastly, when the client receives the sync ACK back, so it's going to receive the sync ACK. At this point, the client is sure that the connection is established. And so server is live. The last thing the client needs to do is just to acknowledge receiving the sync ACK. So it's just an ACK packet, and the ACK number is Y plus 1. Because this guy here observing the initial sequence number of the server is Y, then therefore the next seek num is set to Y plus 1. And that number is also shown in the ACK sequence number. And so server finally receiving the ACK is sure that the client is live and the socket is now complete and in the establishment state. The closing process is actually not exactly three-way. It's actually independent. The client can initiate the closing process the server can also initiate the closing process. And the message exchange is just a pair of fin and ACK. So a fin packet out from the one who wants to close, and ACK will come back from the one receiving fin, right? So there could be simultaneous fin exchange between the client and the server. So the client and the server are both exchanging data. And finally, the client here says, okay, I've finished sending all my data requests, so I'm ready to close. Okay. Then it's going to enter the no longer send but can receive data state. And that is called the send fin, and now wait for the rest of the data to come in. So you see here, the fin packet is the packet with the fin bit on. Server here receiving the fin packet sends back an ACK. Okay, so ACK bit on and then ACKing the sequence number. Server here will enter the close wait. So server knows now that the client wants to close, but it's not quite yet closable because client setting close is just that finishing sending request. There could be some more data waiting to be sent here. Okay, some more ACKs waiting to come back here. Okay, so server needs to finish all these other data that's remaining. But client here receiving the ACK for the fin is pretty much done and just waiting for the server to say everything is already sent, so you're okay. So finally, server says done with all the data. Okay, so sending fin. Client here is receiving the fin, sends back the ACK. Okay, saying good. Let's close. Server can now close safely, no problem. But client here needs to wait 2 maximum segment lifetime before it can really close. And this maximum segment lifetime is usually 60 seconds long. Can you guess why? Why the client needs to stay so long until it can really close the connection?